Hi again. Well, we have defined last time the resources of of our individual, which was actually the time he had and the basically the money he had in addition to the the money he had which he could use without spending his time. Of course, the person can be a woman in that case. We should say her. But anyway, so this, the person has 24 hours, and this 24 hours is divided by L, I, and S, this person gets utility from his or her income and his or her leisure time. And basically, income represents consumption, but we don't go that. We are not interested how he or she spends that money for consumption. We just assume this income leads to him to do something that will bring him or her utility. Anyway, how much is the income of this person? The income is the income that is earned from non-labor sources, which is equal to Z, and the time he or she spends for work, which is equal to L, and W, which is the wage. Of course, we assume that the wage is constant, however much or little he or she earns. In reality, the wage might change if you worked just 1 hour, and it might change when you work for 8 hours, basically. And this person doesn't get any utility from the work he or she is performing, and also not this utility from different works he or she is performing. I mean, work is just something that doesn't give him or her neither utility or disutility. So all work is in a way constant for him, which is represented in L. So, which is something in last week I have talked. In most model, labor work is taken as something homogeneous in the models themselves. Only as side notes, it is mentioned that it's actually not that homogeneous in real life. But anyway, so we, as a starting point, we are drawing utility in different curves, which are representing different disutility levels. So the two variables that are giving our individual utility are the income and the leisure level. So leisure and income gives the people utility. So those are the two variables which will be represented by y-axis. Income will be represented by y-axis, and leisure will be represented with the x-axis, and on the indifference curves, the utility level will remain constant. So, what are the rules we have to draw this indifference curve? The first rule is the more income a person has, the more utility he or she will have. Similarly, the more leisure the person has, the more utility will he or she have. So more income or more leisure will always bring a higher level of utility. Secondly, the utility the person gets from the income gets smaller as the person gets more income. The utility the person gets from leisure will get smaller as the person gets more leisure. Which also means that if you have little income but a lot of leisure, in order to give up a little bit more income, and you have already little income, that little income needs to be compensated by a lot of leisure. Why? Because you have all the income already in a little amount, income will worth a lot for that person. While since you have already a lot of leisure, you need more leisure, will worth less. Similarly, if you have a lot of income and but little leisure, in order to give up 1 unit of income, then now you'll need a very little amount of leisure. Why? Because now you have a lot of income. Your income is less valuable, while since the amount of leisure that you have is little, the leisure is much more valuable. So for the same unit of income, you need a very little amount of leisure to compensate it. So let's go down. So the indifference curve looks very similar to the indifference curves you have seen in the macroeconomics. Basically, while you move along the y-axis, you have higher leisure. While you move through the x-axis, y-axis, you have a higher income. While you move through the x-axis, you have a more leisure, which also means when you move through the origin from the x-axis, if you move through this direction, you will have a higher amount of labor spent by the same person. So one rule is when you move above or right side of an indifference curve, you will come to a new indifference curve which represents higher level of utility. So the utility indifference curves above and at the right side of the indifference curve will represent higher amount of utility. Why? Because when you increase the income or leisure, when you move up, you increase the income. When you move to the right side, you increase leisure. You will get a higher amount of utility. More leisure and more income gives higher utility. And the indifference curve gets flatter as you move along the x-axis. Why? Because when you are close to the origin at the x-axis, in that case, you have a very little amount of leisure, but relatively higher amount of income. Well, first, of course, since both leisure and income gives utility to a person, in order to make the utility remain constant along an indifference curve, when you increase leisure, you need to decrease income, which means that you need to have a indifference curve with a negative slope. And again, that slope needs to get flatter as you move along the x-axis, because at the beginning you have a higher income. When you are close to the origin along the x-axis, you have a lot of income, you have very little amount of leisure. So in order to, 1 unit decrease in leisure need to be compensated with a lot of income. Why? Because leisure is more valuable, income is less valuable. You have a lot of income, not that much leisure. But when you are away from the origin, now income is less, it becomes more valuable. Leisure, you have more leisure, leisure becomes less valuable. So now, in order to compensate 1 unit decrease in the leisure, you need to increase the income only a very little amount. So that's the reason why you have a indifference curve with a decreasing, which is becoming flatter, basically. You might say decreasing slope, it becomes less steep, basically. Since slope is negative, of course, officially, the number that represents represents the slope is becoming larger, it becomes closer to 0. But you might say basically slope becomes flatter. Basically you can say slope becomes flatter. And it's also not I will understand if you say the slope gets smaller. I mean, the absolute number of the slope is getting smaller and smaller, basically. But it's always correct to say the slope is becoming flatter. That's completely right. That's the exact right answer. The slope is becoming smaller is not exactly the right answer because we have a negative slope. Because here the slope is, for example, -5, and here it is -1. -1 is larger than -5 officially. Okay, now the budget. In order to model the decision-making process of an individual, we need a second line, which is called the budget line. Budget line is basically showing us all possible. Indifference curve was showing us. Indifference curve was on an indifference curve. We had the utility constant for different income and leisure levels. On the budget line, basically, we see different income levels for different leisure levels. So it shows for each leisure how much income we will exactly have. How do we do that? We do that in this way. We know that our income is equal to wage time, labor time, plus Z. We also know that basically we have 24 hours which we spent for labor, leisure, and the subsistence income. So our labor time is equal to 24 hours minus S minus leisure. Not small, but large, but small. So basically our Y is equal to V times 24 minus S minus L. And note that this S is a constant. So let's say for our purpose S is equal to 8 hours. So let's make this 16 hours minus L, basically, plus Z would be our budget line. So for example, if wages also constant usually, I mean, given it doesn't depend on the individual, but it depends on the outside conditions of the individual. Z is again depending on the previous, it might depend on the state policies or previous, for example, the family of the person or wealth the person owns. But usually at the decision, it doesn't have any, it is not a factor on which our individual will decide. Our individual will just decide how much he or she will divide time between leisure and the labor, taking S also as constant. So if W is $6, for example, and Z is, let's say, $20, in that case, let's continue to that part in the next part. So see you in the next part. We still have time. So let's do that. Y is equal to 6 times 16 minus L plus Z, which is 20. So this will be our budget line. We can even do it more. I will use 96 plus 20. 6 times L. So Y is equal to 116 minus 6L. So this will be our budget line in this case. So We will continue in the next part. See you in the next part.